Gullies remain an interesting feature to study on Mars, especially because we are still learning about their formation and what processes still act on them. In this observation, we see large gullies on a huge Barchan dune. We've observed these gullies before, seeing that they appear to be active at different times. When we say active, we mean that we can see changes in their appearance between different HiRISE images of the same area. The major objective of this and similar images is to better understand the mechanism for these changes. A specific hypothesis the HiRISE team is investigating is that the changes we see are associated with frost deposits. The frost may be thick and heavy enough to cause parts of the sand dune to collapse, especially if it is lubricated by a layer of gas at the base of the frost layer. The gas would form at the bottom of the frost if sunlight passes through the frost and heats the underlying dark sand, working like a greenhouse. The many large landslides inside Valles Marineris are well known, but there are also landslides elsewhere on Mars. The southwest slope of this crater has at least 3 landslide lobes. What caused the landslides? They might have formed in the final stage of crater formation, but there are fewer subsequent craters on the lobes than elsewhere on the crater floor, so the landsliding occurred long after the crater's creation. Perhaps the landslides were triggered by Marsquakes, either due to impact events or to faulting in the crust. Landslides are greatly facilitated by the presence of groundwater, which could have been present at the time these landslides happened, many millions of years ago. This observation shows dunes in the Martian North Polar Sand Sea in the process of defrosting. Every winter, dunes and other surfaces at these northern latitudes are coated with several tens of centimeters of carbon dioxide frost and ice, plus a minor amount of water frost. The white material is fine-grained frost. The dark, splotchy tones on the dunes may be deposits of particulates deposited from carbon dioxide geysers, or relatively thick deposits of carbon dioxide ice. The more brownish colors represent defrosted areas. Polygonal patterns on the surface of the dunes are probably cracks in overlying carbon dioxide ice. This image was taken in February 2012 in order to compare against another image that was acquired in May 2010. These two images are separated by approximately 1 Mars year. The original image showed a prominent series of dark markings that are the tracks left by boulders as they rolled and bounced down the slope. As they do this, they set off miniature dust avalanches. The bright, fine dust slides away, leaving a darker, larger-grained dust underneath. This follow-up image shows that the smaller dark tracks are gone, and the larger ones have faded considerably. This is most likely due to the fine, bright dust that is transported in the atmosphere falling down and recovering the dark markings.